So, is there a GCF? We want to solve by factoring. The first thing we always do is look for a GCF. Does this have a GCF? No. What's the second thing we look for? Difference of squares. Is that a difference of squares? Right? Remember, two terms like this, both perfect squares like this, and a minus between them, right? So when we factor a difference of squares, we make two sets of parentheses, and we take square roots. What's the square root of x squared? X. That goes in the front of both. What's square root of 9? Back of both. Then what? Plus and minus. Good. You guys remember that, right? Most of you can tell me the two answers now, but you know, if you had to show all the work, here's what we're doing then. If this times this is 0, one of these two factors has to be equal to 0 for the answer to be 0, right? Most of you, like I said, can look at these and tell me the two zeros, but I'm going to show all the work just to remind you what we're doing. So we get positive and negative 3 for our answers. Again, if we went into our calculator and did it, okay, it could be a parabola that opens up and it'll cross at negative 3 over here and positive 3 over here. Okay? But again, if it asks you in directions to solve by factoring, I want to see you factoring it, okay? So do what the directions say. All right, this one, solve by factoring. Is there a GCF? Yeah, it's x, right? So we're going to factor out the x. And then we divide it into each of the three terms. X cubed divided by x is x squared. 3x squared divided by x is 3x. And negative 4x divided by x is negative 4. Now this has got three terms, so it's a trinomial. Okay. And, you know, we had special trinomials, and that was when the first and the third term were both positive perfect squares. They're both perfect squares, but the third one's a negative perfect square. So it's not one of those special trinomials. It's just one of those regular trinomials. And this one's pretty easy because what's my a value? 1, right? So when the a value is 1, the only way to get 1x squared is x times x. So we just put the x's in the front. And then we just look at the c value, the negative 4, and we think about the factors of negative 4 that add up to positive 3. So we got a negative 2 and a positive 2, a negative 4 and a positive 1, or a positive 4 and a negative 1. Which one is it going to work? The positive 4 and the negative 1, right? When I multiply those two, I get my negative 4. When I add those two, I get my positive 3. Remember? So now I got three factors. So I have 3 zeros. And that's what we should find out, right? If it's got a degree of 3, that's how many zeros it should have. All right? And then you just set each one equal to 0. Well, that's done then. And again, those of you, which is probably all of you, just can look at it in factored form and tell me the 3 zeros, and that's fine. But I'm going to show all the work so you understand why we got 0, negative 4, and positive 1 for my 3 zeros. Solving by factoring. Again, you guys, we did lots of factoring earlier this year, and you guys, every now and then, they throw it back at us, right? So this week, we got it back again. Any questions on those two examples? Pretty easy, right? All right, here's another one. Why don't you guys try that one and see how you do, then we'll go over it. Just try this one on your own. I'll give you a few minutes. And then we'll see if we can find all 6 of them. What's your answers? Set equal to 0, right? You take the fourth. Well, you can't subtract. You got to take the fourth root of 0. What's that root of 0? Yeah. You guys are doing good. What's the GCF?
4x.
Yeah, 4x to the fourth, right? So get that. You guys good with that so far? And then you got this trinomial. A is 1 again, so I just look at factors of -6 that add up to +1, which would be a +3 and a -2, right? So that's what it looks like factored. Now, when you set these equal to 0, you know, that's what we do. Right, now first thing you got to do is divide 4 over. Right? What's 0 divided by 4? 0. Right? So we still. So when I do this, we got to divide by 4 first. Then I get x to the 4th equals 0. All right. If it was x squared, we take the square root of both sides, right? Well, if it's x cubed, we take the cube root of both sides. So if it's x to the 4th, we take the 4th root of both sides. That's all. So we just do 4th root, 4th root. When it's 0, what's any root of 0 going to be? 0, right? So that's why it came out to 0. All right, now, since this had a 4 here, we say it has a multiplicity. I usually just do this, but means it works 4 times. We call that multiplicity. So some zeros work more than once. Okay? And then if that only worked once, 2 only worked once, -3 only worked once. Okay? So if that happens, multiplicity, what would happen if you were looking at the graph? It talks about it here. It says sometimes a polynomial equation has a factor that appears more than once. This creates a multiple root. In that example there, 3x to the 5th plus 18x to the 4th minus 27x cubed has 2 multiple roots, 0 and -3. It says the multiplicity of root r is the number of times that x minus r is a factor of p of x. When a real root has even multiplicity meaning it works 2 times or 4 times or 6 times or 8 times, whatever, then the graph touches the x-axis but does not cross it. What did we call that last week? I called it something different than cross. Touches but does not cross. What did I call it? Bouncing, right? That's when it bounces, right? When we looked last week, we had something in parentheses to an even power. We said it bounced, right? And then something to an odd power, we said cross, remember? Well, that's what it's talking about, all right? So when it touches but does not cross or bounces, then it has even multiplicity. when a real root has odd multiplicity greater than 1, if it works once, it's odd. But all right, if it's got a multiplicity of 3 or 5 or 7, the graph bends as it crosses the x-axis. We didn't talk about that last week. Okay. So here's a picture of this one here, 3x to the 5th. That's the graph of that one. Okay. At -3, it hit but didn't cross, meaning it bounced off. That one worked twice. And here, when it went through 0, it kind of bends as it goes through. It doesn't go straight through like we're used to seeing. It has odd multiplicity. It works at least 3 times. So if we look at this degree, see that 5 there? Thanks, Randy. All right, so when you see that odd or that 5, we're looking for 5 zeros, right? So if we look at the graph, we can do that by factoring. All right, we could do that by factoring and get our x cubed out, right? So that equals 0. So only thing cubed that equals 0 is 0. All right, that worked 3 times. So since that's odd multiplicity, you can see that it bends as it crosses the 0. Okay, and if we were to factor this, we take the x cubed out, and then we get 3x cubed out, and then we would get x squared plus 6x plus 9. We could factor x squared plus 6x plus 9 into x plus 3 and x plus 3. Or we could write it x plus 3 squared. I'm sorry, that's a cube, right? All right, so this one, when we set it equal to 0, the x works 3 times. And this -3, when we set it equal to 0, works 2 times. Okay, an even number of times and an odd. All right, so when it works at least 2, an even number of times, 2, 4, 6, it'll bounce like that. And if it works an odd number of times, 3, 5, or 7, it goes with a little bend as it crosses. If it only would go straight through, it only worked once, like we looked at last week. Okay? It says you cannot always determine the multiplicity of a root from a graph. It's easiest to determine multiplicity when the polynomial is in factored form. Okay? So once you get it factored, it's easier to tell. So again, this graph factored is this. Oops, that's 3, not 2. Sorry. There's the 2. So that's what that graph factored form looks like that. So when I set those equal to 0, 0 works 3 times, -3 works 2 times. Okay? So that's something that's a little new to this week, today, is when you look at it as a graph and you see it bending, it works at least 3 times. Okay? So, find all the zeros, a problem like this. All right? Well, these are already factored out, but what's this x squared minus 25 called again? Difference of squares, right? So it's not factored all the way. Okay? There's 2 of these, right? What that means is x squared minus 25 times x squared minus 25, right? And then this was an x plus 2. We wrote it all out, x plus 2, x plus 2, and then the 4x plus 1. All right? So to find all the zeros, I need to factor those 2 things. All right? Let's change the color here for this one. We'll change the color for this one just so. So for this one, square root of x squared, square root of 25, plus or minus. And the same thing here. Square root of x squared is x. 25 is 5. Plus and minus. All right. So we got a negative 5, a positive 5, negative 5, positive 5. We got a negative 2. And then this one, what's that? 0. That's 4x plus 1. Negative 1/4. Yeah. Again, some of you can look at it and tell that to me. If you can't, it's okay. Just set it equal to 0 and solve. You guys know you're going to subtract 1 first. And then you know you're going to divide by 4. So there's where you get that negative 1/4. Okay? So here's what I would do. Now I've got this negative 5, multiplicity of 2. We got positive 5, multiplicity of 2. We've got negative 2, multiplicity of 3. Right? So at these two spots, if we were to graph this thing, what's going to happen at these two, negative 5 and positive 5? It's going to bounce. At negative 2, what's going to happen? It's going to bend as it crosses, right? And then the negative 1/4 doesn't have any multiplicity. All right? It'll go straight through at negative 1/4 if we were to look at the graph. Okay? So we will still be using our calculators and looking at the graphs some, but we're going to mainly this week practice on solving these by factor. Okay? So basically your homework problems are like this tonight. Then tomorrow we'll look at a couple more examples and we'll look at some more like this one. Okay? Today I kept it pretty easy, pretty basic, and just basically it said, now some of these might not be factored all the way on the ones in your homework. So make sure it's all factored first before you find all the zeros. Okay? Any questions? That's basically it today. Pretty easy day. We good? All right, so we got 5 problems for homework. Right there.